Hello and welcome. In this screencast, we'll take a look at net present value and internal rate of return, both very important concepts in introductory finance. So let's get started with this simple spreadsheet here that gives you a bunch of cash flows that occur in various years, year 0, 1, 2, 3, and 4. The cash flows are $350 going out, and so it's negative. It's a negative value, and it's represented as parenthesis because that's how accountants like to show negative values. So a $350 cash flow is going out in the 0th year, that is at the very start of our time interval of interest. At the end of that first year, you have a cash flow of $100 coming in. At the end of a second year, you have a cash flow of $200 coming in. And at the end of the third year, you have a cash flow of $150 coming in, and fourth year, $75. So how do you calculate the net present value of all these cash flows subject to an interest rate of 5%? So in other words, what we're asking is if the cost of our money is 5%, that is, if we were to put this money in the bank, we'd get a 5% return interest rate on this. Now, given that opportunity cost that our money can earn, what if we put this money of $350 inside this venture that yielded $100, $200, and so on over the 4 years? Which is better? Is it better to put money in the bank and earn 5%? Or is it better to put money in this venture and earn this return? We need a way to compare that. So that's what we're trying to find out with the net present value. If the net present value of these cash flows at this hurdle interest rate or at this cost of capital, if the net present value is positive, then it's better to invest in this. If the net present value is negative, it's better to put money in the bank and earn 5% interest rate. So to calculate the net present value, I'm first going to do it the longer way, which is to say that I will calculate the present value of each of these cash flows. The present value is the cash flow divided by the discount rate. The discount rate is the interest rate raised to the power of how much time periods away we're getting the money from. So in this case it is 0 because we are immediately paying off the money. So I'm just going to press enter, and I also want to press F4 so that the F1 cell here becomes $F, $1, so that as I copy this formula down, the interest rate cell remains F1, and I copy this down to all the other cells. So now you have the present value of $100 1 year from now is $95.24. The present value of $200 that you will get 2 years from now is worth today $181.41, and so on for these two. And the net present value is nothing but the sum of all these cash flows, the negative one in the beginning and the positive ones later on, and that is $117.92. Excel provides an NPV function, and we are going to now use that function to calculate the net present value. To use the NPV function, this is how we would do it. I would first add up the initial negative cash flow plus NPV within parentheses the interest rate and all the values, not the first one, the negative one, but all the other values, and that's exactly $117.92. So if we were to put $350 in this venture, which will yield $100 in the first year, $200 in the second year, $150 in the third year, and $75 in the fourth year, then we will be better off by $117.92. So that means that is our gain out of the venture, and we should probably put money in this venture as opposed to putting the money in the bank. Now, that brings us to the concept of the internal rate of return. As you can increase this interest rate, let me just show you this. Supposing instead of 5%, if this was 7%, the net present value has just decreased. If the interest rate was instead 10%, the net present value has decreased even further. So if you can find an alternative investment that pays higher interest rate, then this particular investment appears less and less attractive because its net present value is lesser and lesser. So what is that value of this interest rate, right? Is there a sufficiently high value of this interest rate at which the net present value becomes zero? That interest rate is the internal rate of return. So let me calculate that using this Excel formula, equals IRR within parentheses. Here are all the values. Now I am selecting the first one as well as all the others, and I have a guess interest rate. This could be any number. It doesn't have to be anything at all. I could just put, say, 3% here or something, some reasonable interest rate number, or I can just choose this number here as well. Let me just say 6%. It's a totally random number. I could choose any number here within range. It should be a reasonable interest rate. Okay, I just press enter, and the internal rate of return is 19%. Let me actually make this show the decimals. So this is the internal rate of return. So at this interest rate, if this interest rate was 19.25614%, then the net present value would be 0. Let me see if that is the case. I'm just going to say 19.25614, and you can see that the net present value has become 0. So if your alternative investment can yield something greater than 19.2561%, so if it can yield 20%, then you're actually losing money by putting in this venture because your alternative investment can yield more, and now your net present value is actually negative. So that is the significance of the internal rate of return. How do companies use internal rate of return? They evaluate their projects based on what is the internal rate of return that this project has. So if the internal rate of return is sufficiently high, say if it is 20%, 25%, then you know that the project is probably worth doing because it's going to result in a positive net present value, or NPV. And you proceed with the project. If the internal rate of return is low, like maybe 3 or 4%, then it's more risky to do the project because there could be higher projects that yield higher returns. So that was a brief discussion of net present value and internal rate of return and how the two are related. I just want to leave you with one thought, that is that the NPV function in Excel does not calculate net present value as understood by the finance community. In the finance community, in finance textbooks, net present value includes the initial amount that you put in, and the present value is net of that. Whereas in finance, you do not include the initial value. We have to add the initial value explicitly in the beginning. So I hope you found this useful, and thanks for watching, and check out more videos on Codable.com. Have a great day.